right, we got slides. That's me. My name is Adrian Goins. I'm the Director of Community here at SUSE, and well, I'm going to be teaching you about Kubernetes and Rancher today. So there's all sorts of things on that slide about how to contact me, but don't worry about any of that. Right now, they don't matter. I'm hoping by the end of the class, you'll have learned enough that we'll be good friends. And then I'll show this slide again. If you are a person who does social media stuff and you want to talk about the training that you're in today, just go ahead and use one of those hashtags there, Rancher Training or Rancher Kates, and the social media people pick it up later. Okay, so this is, how many people do we have? Oh my gosh, we have a lot of people. That means it's going to be crazy. I should have gotten somebody to come in and help. It's just going to be me, but I am here to answer your questions. So there's a little questions panel in GoToWebinar. Just when you think of a question, put it there. In fact, let me pop that out so I can keep an eye on it. And we already have a question. Ajaya wants to know if the voice in the video is out of sync. It might be. This is GoToWebinar. It's a platform from the 1990s, and sometimes it does silly things. So who knows? If you have a question, post it there. I'll periodically check it and I'll answer questions throughout. The only thing that I ask is that if you have a question, try to keep it related to the stuff that you're learning here today. If there are lots of unrelated questions, I may not be able to answer them because it's just little. All right, Davi says that the voice and video are synchronized. So Ajaya, if you want to just like exit and come back, punch GoToWebinar in the face, then maybe it'll work a little bit better. We get a problem sometimes where some people will actually lose audio altogether. All right, continuing on, I see people posting that it's not that bad, it's in sync. Let's just keep going. There's some intro and housekeeping stuff, and then I'm going to introduce you to K3S. We're going to install that, and then we're going to go through all sorts of command line Kubernetes stuff. We'll then jump over to installing Rancher, and then we'll do some stuff with Rancher. And then it says final Q&A, but like I said, there's going to be Q&A throughout. There is a repository for today's training. I actually posted that in the chat already. If you want to check that out, there's actually a README in there that literally I like copy paste from. Rancher has tremendous documentation. So just go to rancher.com/docs and you can find answers to everything for all of the stuff that we have going on out there, at least all of the GA, the generally available stuff. If you're looking for documentation related to projects that are still in development, you'll find that in the GitHub repo. But for Rancher, for K3S, for RKE, for RKE2, this is the place to go to get your questions answered initially. And if you have ongoing questions that the documentation doesn't cover, these are the next places to go. Slack.rancher.io, you can get an invitation for the Rancher user Slack if you don't already have one, and the Rancher forums available at forums.rancher.com. Some people like real-time stuff, some people like to post questions and have them answered later and browse stuff. Both of them are tremendous resources that work together. There's like 20-something thousand people registered in Slack. There's thousands of people online at any given time. There's channels for everything. So that's just a great place to come and hang out. Rancher has several Kubernetes distributions. In fact, K3S has actually been donated to the Cloud Native Computing Foundation, so it's not Rancher's anymore, it's the CNCFs, but Rancher created it. It is a super lightweight certified Kubernetes distribution. It's great for edge environments, resource-constrained environments, like maybe IoT, or I guess the edge counts for that as well. Also works fine in data center, bare metal, home lab, whatever you want. It's just super fast and lightweight, and that's what we're going to be using today. You can install K3S directly onto nodes, or you can install it over SSH using a tool called Ketchup that came from Alex Ellis. Alex created OpenFAS and Inlets and a bunch of other really cool projects. He's a big fan of K3S, and we'll be using Ketchup here in just a moment. Stuart is asking if I will post the lab link here. Yeah, sure. 1 second. Send to all. There you go. You should all be able to see that. Oh, yes, I don't actually have it in the slides. For those of you who are just joining, this is being recorded, and within a day or so after it ends, we edit the video down. We'll upload it to YouTube. You'll get an email that has a link to the video and a copy of the slides. Man, yeah, I guess that's it. So if you have to bail for any reason, oh my gosh, there's so many people here today. I'm a little nervous. So if this runs long and you have another commitment or whatever, don't worry about it. It's all being recorded, and we'll get it to you later. Let me actually go and make sure it's being recorded. Yes, totally being recorded. Okay. If you want to do K3s development locally, or if you want to play with Kubernetes locally, there's another really cool thing. We're not going to use it today, but it's called K3D. And it's a way to run multi-node K3s clusters entirely within Docker. Works great on Linux systems and WSL. Works fine on Mac, but the Mac Docker VM isn't shared with the regular Mac host operating system from a networking perspective. So if you use it on Mac, it still works great. You just have to do some port forwarding. This is a wonderful way to spin Kubernetes clusters up and down and play with them and do all kinds of stuff directly on your local machine. Although honestly, if you're running a Linux system, you can just run K3s regularly as well. Also works in WSL too. Let's jump over really quick and do an installation of K3s. Okay, I have 3 nodes. In fact, I have this coming up in a slide in a moment that explains what these are. That's actually not the one I want. Okay, catch up, install. We're gonna go to the demo A host. I'm gonna just SSH in as the root user. We are going to install K3s version. Oh, I don't have my. Is that right? Probably typoed. Yes. All right, so we're going to install 1.19.4 K3s1. And the reason we're going to do that is because Rancher doesn't yet work with 1.20. So 1.19.4, totally fine. We are going to have it save the config file that we use to talk to the cluster as config.a.yaml. And you can see here that that's what it did. And within that file, the cluster is going to be named A. The reason for this is because you can have multiple kubeconfig files to talk to multiple different clusters, and by default, they're all called default. So if you have multiple files and you want to talk to the default cluster, it doesn't know which one to use. So whenever I install something, I specify the file I want it saved as and the name that I want the cluster to have. That file looks like that. It's got a bunch of TLS certificates for communicating with the cluster, but you can see here that it's demo A, and the cluster is called A. It created a user called A, created a name called A. And there are utilities. In fact, if you look at the README that's in the repo, there's a lot more information. That's actually practically a training session by itself. There are utilities that you can use to make talking to and managing Kubernetes clusters easier. One of them is called kubectx. Another one is called kubi. And here I have an abbreviation for kubi. Kubi will point to that cluster now. But if you don't have any of those utilities, then really all you have to do is point the environment variable kubeconfig at your config file. Now I use the fish shell, so it would look like that. If you use bash, then it would be like that, just export it. The point is you want that variable to point at the config file, and there's our cluster. So I spent way too much time talking about that. That cluster came up in about 15 seconds, which is blazing fast for a Kubernetes cluster. Okay, I've got people asking me to post the repo link in the chat. It's already posted, or not in the chat. It's already posted in the questions panel. I'll post it again. But if you open the GoToWebinar panel, whoops, that's not it. If you open the GoToWebinar panel, you should see a chat window. Send to all. And I'll post it again there as well, just in case it doesn't show people previous chat when you first log in. So it's in the chat window, it's in the questions panel. We should be good to go. Is the font size on this terminal big enough? Let me know. And if not, I'll make it bigger. Yes, 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 yes. Okay, good. Everybody says yes. Thank you. So that's a Kubernetes cluster. Now you see that I'm typing k get nodes. It's actually kubectl get nodes. That's the name of the command, kubectl. You're going to type these commands so many times that you're just going to start making abbreviations for them. And the first abbreviation that everybody makes is just k equals kubectl. So k get nodes, if you see k, it just means kubectl. Hooray, we have a Kubernetes cluster. Oh my gosh. Now, these are the 3 nodes that I'm going to be working with here in my house. I'm located in South America in the Central Valley of Chile, about 3.5 hours south of Santiago in a 7.5 acre or 4.2 hectare plot of land. So I have my own lab environment here with a caching server and my own internal domain name, and that makes it easier for me to do work for these kinds of demos. So demo A, demo B, and demo C are the 3 machines that we have today. The Rancher environment is going to be ranchertraining.cl.monakas, but we're going to do most of our work in this class actually on the CLI talking to Kubernetes. If you're here, and the 161 of you who are, you probably already know what Kubernetes is. I don't think anybody stumbled into this class being like, I want to know what Kubernetes is. You already know. It's the, oh my gosh, everybody's using it. It took the world by storm, the thing for container orchestration. And that's really all it does. It's the glue around deploying and managing container workloads. It wires them together, it gives you services and ingresses and does routing and cross-host networking and all of this stuff that we used to have to do ourselves that was brittle. It takes that brittleness out, but it replaces it with a massive amount of complexity that in the beginning is daunting. My objective today is to strip away all of that initial, where do I get started with this ball of yarn that some of you are feeling? And by the end of the class, to have you feeling confident that you understand the basic components of Kubernetes and how to deploy and use them. The architecture of Kubernetes is simple, but there's some terms that you have to know. There's the control plane, the data plane, and then worker nodes or the worker plane. The control plane is an API and some other components that handle, they're the brain, basically. So when we run kubectl something, it hits the API server, does all kinds of authentication and authorization to make sure that we're allowed to do whatever we're asking, and then it takes our request and it goes and does something with it. The long-term storage, what you can think of as like the database of Kubernetes, maybe that's the brain, I don't know. Is the brain more about the memory or is the brain more about the processing? Or both? Well, that's the data plane. In a full-size Kubernetes cluster, this is handled by a thing called etcd, but all it is a key value store. So in K3s, on a single node cluster like we just built, it's actually handled by SQLite. You can also plug K3s into an RDBMS like MySQL or Postgres or MariaDB or an external etcd store, because it's just key values. So you have the control plane, the API, the data plane, etcd or something else, and then you have worker nodes. And worker nodes are where your workloads actually run. It's possible to have all of those functions on a single node, which is what we have now. So our single node Kubernetes cluster comprises the control plane, the data plane, and the worker plane, all in a single node. As your clusters get larger, you're going to want to split that functionality out because you don't want a situation where a workload can hijack all of the resources that Kubernetes needs to function, which then creates a cascading failure and things burn. And I guess we can't say things burn anymore because OVH data center burned. Bad things happen. We'll just leave it at that. So that's all you really need to know for today about the Kubernetes architecture. Let's see, Nick says, is everything you're showing here today appropriate for a production or enterprise environment, or is this more dev test? It's all appropriate for a production environment, absolutely. We're gonna be doing some really basic Kubernetes stuff, running like the equivalent of Hello World. So the workloads themselves, they're not like big production workloads, but the skills that you'll be learning totally are. Philippe says, am I supposed to see the chat? I only see the GitHub link you posted. Well, there's nobody else chatting in the chat, so yeah, I'm the only one. All right. Kubernetes, complexity. Don't be afraid. There's lots of things that it can do, but it all starts with these 6 things that you see on the screen. Pods, replica sets, deployments, config maps, services, and ingresses. With these 6 things, you can build an application. Now there's other stuff. There's persistent storage, there's security policies, there's things like that. But for today, don't worry about them. What you're going to learn today is the core. And then when you want to know something else, you can go to the Kubernetes documentation and you can learn about just that piece, and then you can bolt it onto the knowledge that you have. We're just going to get you up and running with these core things. And we're going to start with pods. A pod, questions? For those of you who are showing up late, yes, the class is recorded. You'll get a copy of it afterwards. Yeah, okay, so 2 people were asking that question. All right, so a pod is the smallest thing you can deploy inside of a Kubernetes cluster. It's a logical representation of 1 or more containers. Quite frequently, it's just 1 container. But if you've ever done anything with Docker where you have like 2 containers that you need to get to talk to each other, and then you've got to do all that linking stuff with the variables, and then as you try to scale that up, it becomes really complicated and stuff cross and whatever, and then you put it on different hosts, and oh my gosh. Kubernetes pods simplify that. You can have multiple containers in a pod. They share the same network space. They share the same storage. They share the same PID space if you want. There's some other stuff you can have them share. But by default, network space and storage, which means now you have 2 containers that can talk to each other on localhost and that can talk to the same disk. That's pretty powerful when you want to build a microservices application where you've got 1 process for each container. Best practices for container development say that you want 1 thing for your container, and that's it. 1 thing, that's its process, that's all it does. But if you've ever tried to build a container where multiple things need to talk to each other, like I always use the example of Apache and PHP. So you've got, the Apache web server, and then you've got a fast CGI running PHP. And if you want to put those in the same container, but now they're different processes, so now you put an init system in there, like supervise or run it, and then you're building a Linux system. And that's not what containers are for. Pods solve all of that. Oops. So here's an example from the Kubernetes documentation that shows a file puller that pulls content from a CMS and saves it to a disk, and then a web server that takes that content off the disk and serves it out to consumers. This is a perfect example of a pod. Together, these things form some core functionality of an application. And when that core functionality needs to grow, when you need more horsepower, when you need to serve more requests, then you scale up the number of pods. 1, 2, 5, 10, 1,000, whatever. But you're scaling up the functionality of the application. So make sure that whatever you put into a pod is related to one another. You wouldn't, for example, put a web server and a database server in a pod and then scale them to 100. Because when you need more web servers, you don't need a linear number of database servers that wouldn't even be able to talk to each other. It's a terrible example, but it demonstrates the point that what goes into a pod should be related. Everything in Kubernetes happens via what's called a manifest. Manifests are written in YAML. You can also write them in JSON. Whatever, they're written in YAML. I'm trying to keep things simple. So they're written in YAML. All manifests have, most manifests have 4 top-level keys: API version, kind, metadata, and spec. Here we have the basic manifest for a pod. API version v1. That just tells Kubernetes where in its API definition it can find how to create the thing that we're asking it to create, in this case, a pod. Metadata we talk about later. Spec is the definition of the thing. In the pod spec, there's a key for containers, makes sense, underneath which is a list of 1 or more containers, also makes sense. A container in that list needs at a bare minimum a name and an image. But in our case, we're also passing a command to override the command that's in the container by default, in the container image. So in this case, the BusyBox container would normally just spin up and then die. But we're going to tell it, echo hello Kubernetes, and then sleep for 1 second. And if we go and run this, I want you to think what is going to happen when it exits. Natalie is asking, would you recommend using the embedded etcd for production? It's added full support since version 1.19.05. We want to use 20.04. Yeah, anything later than 1.19.5 for the embedded etcd in K3s, totally fine. I have to move this questions panel out of the way so that I can get to my notes. Where are we? We're down in pods. Okay, so if you're following along in the README, oh, that was easy. Oh, except I didn't switch to terminal. There we go. So I just ran kubectl apply, and I pointed it at a file. That file is that right there, which is the exact same file that I just showed you on the screen. Now, this created a pod. And we're going to run kubectl get pods. You can also abbreviate things in Kubernetes. And rather than continuing to run that, I'm going to add -w, which says wait. And when there's a state change, tell me about it. So you see, actually, there were some state changes already. So it went running, which you didn't see. Then it went completed. Then it went crash loop back off. Crash loop back off. Unless you specifically tell Kubernetes that the thing you want it to do is going to run and then exit, Kubernetes expects that it's just going to continue to run. So when it exits, Kubernetes restarts it. And it exits, and Kubernetes restarts it, and it exits, and Kubernetes restarts it, and it exits, and Kubernetes is like, whoa, clearly something is wrong with our relationship. So rather than just restart you, I'm just going to give you a couple of seconds. Okay, now I'll restart you. Oh, you exited again. Okay, I'm going to give you 4 seconds. I'm going to give you 8 seconds. And it continues to increase that back off timer between restarts, continues to back off the timer between restarts. So that's a better way to put it. That's what crash loop back off means. Kubernetes doesn't know that we told it to exit. It just knows that it's exiting. Maybe it's waiting for a cache or waiting for a database or waiting for something. Kubernetes doesn't know, but it's not going to let a resource just spin out of control, dying all of the time, because that takes away resources from the system that could be used on other workloads. It wants to protect the system, so it will continue to back off incrementally all the way up to 10 minutes between restarts, hoping that either it fixes itself or a person comes along and realizes that something needs to happen. In this case, I'll be that person, and I'm going to fix this by just deleting the pod. Boom! I like deleting things in Kubernetes. I like deleting things in cloud computing in general. One of my favorite things about cloud computing is that deleting stuff is just a totally viable troubleshooting step. Like rip and replace, like it's just so awesome. I used to build data centers. You build a relationship with your hardware, and now no relationships, just build a new one. So that pod's been deleted. And let's move on to talk about what we just did. Quick check of the questions panel. Ah, all right, Srirangam noticed that my shell is kind of smart. That as I start to do things, like things are grayed out. This is a function of the fish shell. I use the fish shell, which is directory aware context history. So it knows when I was in this directory, this was a command that I recently ran, and it's just fantastic for shell history. So that's the fish shell. Anyway, I get that question a lot. I really love the fish shell. I'm a huge fan. So what we just did is fine. We did a thing, and then we did another thing, right? Like that's totally cool. And we're going to do a lot of that today. But I want you from the beginning of your Kubernetes journey to consider that if we just deployed a workload, a production workload, really important, mission critical, and then we change some stuff and it's totally running, and then we close our laptop and we go on vacation, and then it crashes. And I'm on a sailboat out in the Pacific Ocean scuba diving with whales or something like that. My colleagues have no idea what the state of the cluster was. They don't know what I did, and it's going to be a lot harder for them to fix it. So while building manifests and applying stuff directly to the cluster is fine, and you're going to do it a lot, think about how to make sure that what you do can be repeated by other people without being dependent on you. If you do anything with configuration management, Ansible, Puppet, Chef, those things, then you're already familiar with this. If you're old school, you remember CF Engine. You're already familiar with these sorts of concepts. You don't go on a machine and install some software. You update the Puppet manifest and Puppet installs it for you, and then it protects against configuration drift and all that stuff. You want all of that for Kubernetes. And there wasn't really a good way to get it until some people came up with a tool called Kustomize. Kustomize introduced templating for Kubernetes manifests that now enabled you to put them into a Git repository. And that led the way to GitOps. GitOps is a whole methodology that says that the Git repository is the source of truth, and we never apply changes directly to the cluster. We might test them locally, but then we commit them to the repo, and something inside the cluster pulls them down and applies them to the cluster and does all that same stuff, protects against configuration drift, and if they change, it reverts them and stuff like that. Now, I'm out in the Pacific Ocean, the cluster crashes, my colleagues just build a new cluster, point it at the repo, and boom, everything's back, except for data. That's backups. That's a different story. I have customized stuff in that repo so that you can see it. And I don't do it in this part of the class, but if we get to it, if we have enough time today, there's so many people here, whatever, if we get to it, we'll use it with the Rancher portion. So I just want to throw that out there so you can start thinking about it. Replica sets. A replica set, all right, well, let's back up. We created a pod, and the most that Kubernetes knows how to do is restart the pod if it dies, and that's what you saw it did. But what if we wanted to scale the pod? We don't have any way to do that just within the pod resource itself. We need something to babysit them, and that's called a replica set. So a replica set defines the scale and state of a group of pods, and it introduces a thing called state management. There's two types of state that we talk about. One is this, and the other is stateful and stateless applications. This state management is the desired state versus the actual state of the Kubernetes cluster. It's easy. When we say kubectl do something, we're not actually telling Kubernetes what to do. We're saying our desired state for the cluster is this. There's currently 0 pods. Our desired state is 1 pod. And Kubernetes figures out how to make that happen. It figures out what node to put it on based on parameters. It decides, and then it does. And it reconciles those two states. Desired state 1, actual state 0. Let me go make a pod. Oh, that pod crashed. Well, the desired state is 1, the actual state is 0. Let me restart it. Easy. With a replica set, now we can say that the desired state is 5 of those pods. And Kubernetes goes, oh, well, I only have 1. Let me make 4 more. And that's state management. Replica set is the first place that is introduced, but you're never actually going to create replica sets. You just have to know what they are. That was easy, right? We used to create replica sets, but now we create a different thing called a deployment. Here's a picture for the desired and actual. We've got 12 replicas. The node crashed. Now we have 8 replicas, but we want 12, so Kubernetes puts 4 of them on the remaining 2 nodes. It's easy. You can tell Kubernetes, so you can tell Kubernetes what to do. You can say, put this pod on that node, and it will do it. But you don't want to do that because if that node goes away, that pod doesn't go anywhere else. When we get to the metadata section, you'll learn about labels, which are criteria. And you can tell Kubernetes, put this on a node with this label, and then it will do that. And now, of course, if there's only one node with that label and the node goes away, then you have the same problem. But now you could have multiple nodes with SSD drives, and you could say, put this pod or this workload on a node with this label of fast disks or whatever, and then it'll move stuff around and it takes care of it for you. So you're still defining the framework, but letting Kubernetes make those decisions. Philippe, I love questions that start with, I know I'm jumping the gun. Oh, Philippe. Philippe, are you the same Philippe? You posted this in the forums, didn't you? You're stalking me in a good way. I'm not going to be able to answer that question here, but I recognize your question, and I saw you posted it in the forum. I will get back to you on that. Ankur says, Ankur says, I wish that we had more back and forth in this. Like it, again, GoToWebinar being what it is, having to do this like asynchronous talking, answering questions thing. I wish we could have like a Zoom call, or I could see you raise your hands, or I could invite you on the show or whatever. So sorry that it's not more interactive. Ankur, using Rancher 1.6, planning to migrate to Kubernetes, some concepts co-related, but not all. Yeah, if you're on Rancher 1.6, you are still using Rancher Cattle, which had a lot of similarities to Kubernetes, but was being developed more slowly than Kubernetes, just because it was being built by Rancher versus everybody. So that's why Rancher pivoted and built a management platform with Rancher 2 for Kubernetes. So yeah, there is, you should move that along. There is a migration path to get from 1.6, but you're going to have to rebuild all your workloads and migrate them to Kubernetes, and you're going to learn a lot today about how to do that. So I told you that you don't have to worry about replica sets because you're going to build deployments. A deployment sits above a replica set. So a deployment creates a replica set creates pods. You can really just think of it as a deployment creates pods. Some of the other people who give this training, they don't even like to talk about replica sets, but I think it's important that you know that they're there, even though you're never gonna talk to them. So a deployment gives more functionality for managing a workload, and that's where we're going to spend a fair amount of time. You can do things like you can update the image, you can scale it, you can roll it back. You can do all of the other stuff that you can do with the replica set because that just carries directly through. Remember that you don't directly talk to the workload. You talk to the API server who translates your requests, your desired state into something. So here we have a deployment. We want 3 replicas and we want it to run this version of Nginx. If for whatever reason, something that we launched went away, well, it will maintain that state by recreating it. We've seen this already. Green check mark. I guess that's good. Let's go and actually make this happen. Here we have a deployment. It's in YAML. And you're probably thinking, I'm never going to remember how to write that. And you're right. None of us do. Don't worry about it. There's lots of ways to do things. There is lots of ways. There are lots of ways. That's interesting. It's easier to say there's lots of ways, but it's actually grammatically incorrect. But there are lots of it doesn't work. There are many ways in Kubernetes to do things. I'm going to show you lots of them today so that you can decide the one that you want to do. But I guarantee you, nobody sits down and just writes YAML from scratch. We all either copy pasted or use generators or something like that. So don't worry about it. Here's a deployment. API version, apps v1. Lost my mouse. PowerPoint always steals my mouse. Apps v1, kind is a deployment. Spec. Now we get into some interesting things. If you look down under template, you'll see that everything under here looks very much like the pod template or the pod spec that we were looking at a moment ago. There's metadata, there's spec, there's containers, and then there's what appears to be, a list of containers. And there's some other stuff in here, but don't worry about that. Deployment creates a replica set creates pods, ultimately deployment creates pods. Therefore, you're exactly right. This is the definition of the pod. We could take this out and just make it a pod and it would work just fine. But in addition, we have this replicas field, which tells Kubernetes the number of pods that we want it to create. And now we get into metadata. Let's start, hang on. There we go. Let's start with the metadata for the deployment. Everything needs a name. Okay, and then you see we have labels. Labels are arbitrary key value pairs. You can set them to whatever you want, as long as what you set them to uniquely defines the thing. At the very least, best practices say you should have app is whatever. App is Nginx, but you can have other stuff. Environment equals production, business unit equals finance, well, whatever. Data center equals something. Where labels start to be cool is you see down here in the deployment, it has a thing called a selector, and it says match labels app is Nginx. The deployment needs to know what pods it should care about, and it does this by looking at labels. Pretty much everything in Kubernetes happens with labels and selectors. So it says, I will care about all pods that have the label app is Nginx. And down under the template, you'll see that the pod will be created with a label of app is Nginx. Huh, that's pretty easy. Now be careful with this, because if we spin up this deployment and then we go and spin up a deployment that's also called app is Nginx, they will each care about each other's pods. Kubernetes is just going to do exactly what we told it to do. So you may need additional labels. App is Nginx, environment is staging. App is Nginx, run the 1.16 Alpine image. This introduces us to kubectl get deploy, which then we can also say get replica set, and then we can also say get pod. And if you look at their names, you'll see that it went from Nginx to Nginx dash something to Nginx dash something else. The pods include the name of the replica set to which they belong, and then the replica set includes the name of the deployment. So from the pod, you can figure out what the actual thing is. So far, we've been looking at, wow. Yeah, I just see a whole explosion of people saying no sound, sound, no sound, sound. Okay, you know what I'm going to do? I'm going to actually, I will record this locally as well. Yeah, okay, so I'm going to record this locally as well, just in case GoToWebinar eats the sound. Okay. Well, trying to decide, should I repeat what I just did? Sound okay now? Drop briefly. Can you please share a link to recording? Yes, there will be a link to the recording. Repeat the part just before the creation of the deployment. Okay, you know what? I will. I'm not sure where it went out, so I'm going to nominate, let's see, Oxiel Contreras, you are nominated to answer my questions. From creation of deployment. Okay, so do you need me to explain the deployment and all the selectors and all of that stuff again? Yes or no? Just Oxiel. No. Okay. So you saw that. Do you need me to explain this again? The deployment, the replica set, and all of that stuff? Yes. Okay. Got it. So we did k create deploy Nginx, and we told it create it with the image Nginx 1.16 Alpine, and it said okay. So now we have kubectl get deploy, kubectl get replica set, and kubectl get pod. And you can see that the deployment is called Nginx, the replica set is Nginx dash something else, and the pod is the name of the replica set dash something else. So each of these contains the thing that owns it. The pod's owned by the replica set's owned by the deployment, and that makes it easy to figure out what belongs to what for us as a human, as human beings. Arnab asks a question. There are so many of you. It's not normally this disjointed, but I want to make sure. Otherwise, I'm going to end up with like 400 questions at the end. Arnab asks why people should move from cattle, Rancher 1.6, to Kubernetes, and the primary reason is because cattle's not under development anymore. Rancher started when there was just Docker, and there was no orchestration for Docker, and so Rancher created Rancher Cattle, and it was an orchestration engine for Docker. And then somewhere along the way, Google released Kubernetes and people started using Kubernetes, and the rate of adoption of Kubernetes was greater than the rate of adoption for cattle, just because there were way more people doing development of Kubernetes. So along the way, we realized that we were basically building Kubernetes more slowly. So that didn't make any sense at all. So it was a very painful decision, but we decided to take our baby and put it to sleep. That didn't sound right. We decided to take Rancher Cattle and stop developing it, and instead invest resources into helping Kubernetes be better. Like, we didn't want to compete with Kubernetes. We wanted to help the community and the ecosystem just be awesome. So we took Rancher and we made it a management platform for Kubernetes. And since then, we've been building additional value for Kubernetes. And the reason that you should use Kubernetes is because that's what everybody is using, and that's the only thing that people are going to be using for the foreseeable future. So invest in your career, learn how to do stuff with Kubernetes. Otherwise, well, yeah, just do it. Randy wants to know, can you name your replica set rather than leaving it as a random value? You could, but you don't need to. It doesn't matter. Yashwant says we're seeing more about Kubernetes here than the use of Rancher with Kubernetes. Yes, this is an introduction to Kubernetes and Rancher class, but it's mostly an introduction to Kubernetes class. Because if you don't understand Kubernetes, then what Rancher does for Kubernetes, it's just magic. But I want you to understand Kubernetes. I want you to be able to go anywhere where Kubernetes is in use, even if they're not using Rancher, and be able to use Kubernetes. All right, let's back on track. So we've been looking at YAML. YAML is like, it's the bones of a thing. It's how that thing is created. Like, if you could take it and like open it up and be like, what's inside of you? But there's another way that we can view information about workloads, and that's how Kubernetes sees it from the outside. And that command is kubectl describe. This is how Kubernetes sees it, and it gives us a lot more information, like what host is it on, what's its IP address, various other things about what's going on inside of it, various states about it. But then let's make it 3. Now we have 3. Woohoo! Notice they all have the same prefix, but now they have different suffixes. Let's delete one of them. Desired state, 3. Actual state, 2. What does Kubernetes do? Gives us another one. Notice it's only been around for 6 seconds. It's not hard. It makes sense when you just take a step back and you're like, oh, okay, yeah, that totally makes sense. Now, let's upgrade and let's actually break it. kubectl set image, deploy the deployment called nginx. Sometimes I use a slash and sometimes I don't. Honestly, it doesn't matter. It's exactly the same thing. Whatever. Even though we only have one container in the pod, we still have to tell Kubernetes which container we want to upgrade. Ours happens to be called nginx, and we want it to run 1.17 Alpine, but I'm going to misspell Alpine. When you do an update or a rollout, there's a command called kubectl rollout status. And this will update as your rollout happens. So we could sit here for a while and nothing would ever change. But let's just pretend that we sat here for a minute and we're like, wow, that seems to really be taking a long time. I wonder what's wrong. You always start with kubectl get pods, period. Like that's just, you want to know what's the state of the system, that's going to tell you. And you see now that we have a pod with a state of error image pull. But notice, even though there's an error, our original 3 pods are still running. The application's up, customers are buying stuff, our boss isn't going to get mad, we're not going to get fired. We have the time to figure out what the problem is. And we do that by using kubectl describe pod. Because error image pull, we want to jump down to the events section and see the actual error message. So here you see it was assigned. Okay, there's the error, back off, yada, 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 and failed to pull. Actual message is failed to resolve reference, not found. And then we realize, oh, we misspelled it. Shoot. Well, easy enough to fix. kubectl rollout undo. Really, we're losing audio again? Okay, there's nothing I can do about that. Checking my network statistics here. Yeah, we're just going to keep going. At least I'm recording it locally, so if the GoToWebinar copy has audio dropouts, I'll be able to put the audio back in. So sorry, but let's just keep going. The good news is we're going to not be using GoToWebinar here in the next couple of months, and I'm pretty excited about that. I've been doing this training for 2.5 years, and I have nothing good to say about GoToWebinar. This kind of stuff happens all the time, so I'm hoping the new platform is better. Okay. Yep, all right, everybody says it's back. Well, continuing. We're just going to undo that rollout. I should learn sign language. So it was rolled back, and now we say kubectl get pods. You can see that we just have our original 3. Now, if that rollout had actually completed and we did kubectl rollout undo, it would actually roll it back to the previous state. So whatever the previous state was, it'll roll it back to. In our case, it was just nuke that pod that it was trying to create. And now let's do it differently. If we run kubectl edit, it will actually go out to the cluster, grab the manifest, bring it back, load it into our editor, and let us change it. Remember all that stuff I talked about declarative and repeatable actions? This is not one of those, but it's a good demonstration of just the power and the functionality of what you can do with Kubernetes. So when I save this, now the rollout will actually happen as it goes and gets the image and does its whole update and stuff. Dun, dun, dun. No more questions for the moment. Oh, there we go. Rollout continuing and stuff being terminated, and boom. Now we are running 1.17 Alpine. Hooray! It's not in the README, but I want to show you one other way to create content, to create the manifest that you're applying. So we had this command, kubectl create deploy nginx, and then the image, right? Well, I can say -o YAML, so that says output it in YAML. You can also do JSON or probably something else, I don't know. And then dry run equals client. And what it's going to do is it's actually going to take the manifest that it created, but instead of applying it to the cluster, it's going to show it to me in YAML. So I could just redirect that to a file, and then I could just edit that file and add any additional stuff that I needed to. Another super cool thing that will save you is kubectl explain. Right. So let's say that I wanted to know how the containers block was supposed to be formatted, right? So this is deployment spec template. Actually, we can do this as a pod. So because the template is the same as the pod, so let's say it's actually pod spec containers. Pod spec containers, right? And it will, well, let me pipe that to less. And it will actually show me the man page for everything related to that particular leaf in the tree. And I can drill down into any of these. If I wanted to know, env from, for example, well, then I can just say .env from, and now it will show me everything for that particular thing. So if you forget the exact syntax for volumes from or env from or something like that, it's all right here. Plus Kubernetes has amazing documentation themselves that will save you. If you are planning at any point to go for your certified Kubernetes administrator exam or any of the others, CKSP or CKAD, you're allowed to use the Kubernetes documentation, but this is also super helpful if you're like, I don't remember exactly the syntax of whatever. kubectl explain. So at this point, we've got some pods, but we can't really talk to them. So what do we do? Service. Pods have IP addresses, but you can't trust them because it was assigned to the pod when the pod was created. But pods, it might get deleted, it might get upgraded, the node might come under pressure and the pods might be evicted and started somewhere else. Kubernetes can move things around sometimes if it needs to preserve the health of the cluster. So when a pod shows up somewhere else, it's going to have a different IP address. In fact, that IP in the future might even be on a totally different pod from a different application. So you're never, ever, ever going to talk to the IP of a pod. Instead, you will put a service in front of pods. A service gives you a stable DNS name and a stable IP address, and then it creates what's called an endpoint, and Kubernetes updates that endpoint with the pods that match the selector with their IP addresses. So when a pod goes away, it comes out of the endpoint and the service. It's basically a layer 4 load balancer. And so now one of the backends goes away and it just routes against the ones that remain. And you can do cool stuff with pods where you can have a health check probe called a readiness probe that says, okay, the pod is busy, don't send it any traffic. So maybe it's like, chewing on an image or something like that. If it's doing some kind of processing, you don't want Kubernetes to kill it, but you don't want to send it any more traffic. So you can have a health check that says, I'm busy, and then it'll just fall out of the service until that health check passes, and then it'll go back into the service. Now, there are 3 kinds of services. Each one contains the type that came before it. Cluster IP service. This is a service that exists only within the cluster. So you've got some web servers and they need to talk to Memcache or Redis or something like that, where it's just in the cluster. So it creates an IP and a DNS name within the cluster's IP space. Next is a node port service. A node port service first creates a cluster IP service, then it opens a port on the cluster. That port is between 30,000 and 32767, and it opens it on all nodes. Traffic that arrives on that port is routed to the cluster IP service and is then routed to the pods. The third one is a load balancer service. If your cluster is in a cloud provider, and if it knows it's in a cloud provider and has been configured with permissions to talk to the cloud provider's API, then when you create a load balancer service, it first creates a cluster IP service, then opens up a node port, and then it reaches out to the cloud provider and it provisions a cloud load balancer, whatever that happens to be. In Amazon, it could be an ELB or an NLB. It then configures it with the port and the hosts and all of that other stuff, and it maintains that configuration for the life of the service. So if you add more nodes, if nodes go away, if anything changes, it maintains that configuration at the top. If you are running in private cloud, bare metal, virtual machines, basically anything that's not in a cloud provider, you can do load balancer services with tools called, so there's one called Metal LB, there's another one called KubeVip, and these work by, you allocate them a block of addresses, and when you create a load balancer service, the KubeVip or Metal LB controller will take one of those addresses, assign it to a node, and then begin announcing it. And it will either announce it via layer 2 ARP, or it will inject it into BGP fabric if you have that in your environment. And then it does all the same stuff. It'll move it around between nodes if necessary. They're great. I run Metal LB here at the house, and I just released a video on setting up KubeVip and Metal LB for bare metal Kubernetes clusters. Oh, look, it's a picture that describes what I just said. I forgot that slide was there. So let's go and create a service, and I'll show you how this works. Dun, dun, dun. So the easiest way, oops, okay, expose, deploy, Nginx. Yeah, let's actually look at the service YAML using that trick that I just showed you. PowerPoint stole my mouse again. If any of you use a Mac, and if you ever do a PowerPoint presentation and your mouse disappears, I don't know why this happens. This is like Mojave, Catalina, and probably Big Sur. Do Command Shift 4 and then escape. So like you're gonna do a screenshot, but then escape and your mouse will come back. It's the only way to get it back. I don't know why PowerPoint does this. You didn't like that. Dash. Well, you know what? Let's just look. Let's launch something new. Let's get rid of that. And let's create deploy demo. Okay. The error that I had a moment ago, if you saw that, it said couldn't find port via -- port flag or introspection. When we created the Nginx deployment, we didn't tell it what port to expose on the containers, so it didn't know. So when we said kubectl expose, Kubernetes was like, I don't know what you want me to expose. Like, you didn't tell me, there's no port. So I just created a new deployment called demo, and I said expose port 8080. That's probably up and running. Nope, it's not. It will be soon. In the meantime, like demo -o YAML, there we go. Okay, here's what a service manifest looks like. Let's start with the spec. The service is going to listen on port 8080, and it's going to send to port 8080 on the container. The selector is app equals demo, because our deployment has a selector, because we called our deployment demo, so by default it just gave everything the label of app equals demo. And there's no type listed here, but it would be type cluster IP. Now, if I said type equals node port, type equals, this is probably in my notes, is it? Create deploy. Yeah, type equals node port. Okay. All right, so here you can see that port 32167 is being routed to port 8080. And that's up. So if I were to do curl-i demo-a colon 32167, yeah, we get a 200 response. And if I were to go to that in a browser, well, there's a thing. But nobody is going to say, oh, my website is example.com colon 32167. Come check out our stuff. So this doesn't work unless you have some kind of external load balancer sitting outside, whether that's a cloud load balancer, NetScaler, F5 Big IP, something that you can't control from within Kubernetes. And honestly, these days you can control pretty much everything from within Kubernetes. But there's still value in opening up node port services. Maybe you have a database and you just need to real quick load some data into it before closing off the port. So rather than opening 3306, you could just open whatever arbitrary port you want and then connect to it that way. Let's update this because I really don't like the blue. So let's use what we've learned so far and let's add an environment variable. So here we have our container. We only have one. Let's give it an environment variable of cow color equals yellow. And when we save that, you will see that it's going to start rolling stuff out, and it's probably already happened. If I jump back to the browser, you can see that the blue cows are fading out and the yellow cows are fading in. There'll be a third one here in a second. There you go. You see the little green flag that's moving across that shows it's a layer 4 load balancer. I call them dumb load balancers. They don't do anything other than receive traffic, and it's just going to round robin it across the pods that remain. And that's fine. How do we make this more useful? First, we check the questions panel. Philippe says, is Ingress Nginx not a load balancer like Metal LB? It is not. We're going to talk about ingresses in right now. Look at that. It's on the screen. James wants to know, why are node ports so high? So there's a restriction in Unix where you need to have root privileges to open a port lower than 1024. So they could open ports, from 1025 and higher if they wanted to, but a lot of those ports are already taken by other things. Ports above 30,000 generally are ephemeral, so there's nothing that actually owns it. And they just chose, 30,000 to 32767 because, 32767 is actually a boundary of a binary address space. And I don't know why they started at 30,000. You can change that. If you had something else that was already using a portion of that port space, you could use other ports if you wanted to when you launch your Kubernetes cluster. You could say service port range or node port range is this. It's likely to be available, I think, is the only real reason. All right, ingresses. Let's recap for a moment. You had pods, replica sets, deployments, services, and now ingresses. And the easiest way to describe why an ingress is valuable is because it solves a problem. Like services, think load balancer services. If you have 1,000 websites running in your Kubernetes cluster, you don't need 1,000 cloud load balancers at $20 a month. Like, we solved this problem back in the early 90s with name-based virtual hosting. Anybody remember that? Now you know how old I am. An ingress is a layer 7 load balancer that sits above multiple services. And by layer 7, it means it's an application level load balancer. It receives traffic and it actually looks at it and it analyzes it and it makes decisions. They deal with HTTP type traffic. So REST APIs, HTTP, HTTPS, if you do SSL termination, those kinds of things. It's not going to be able to understand MySQL or MQTT or those. You can punch TCP ports directly through, but you're going to use an ingress basically as a layer 7 HTTP load balancer. You can have one ingress then, and it can route to multiple services based on host name, based on path, based on lots of other stuff. And the thing that so ingresses are where the naming in Kubernetes starts to deviate a little bit. What I create is actually an ingress. But all that is a configuration that I've applied to the cluster that indicates my desired state. I want something to receive traffic, and when it comes in for this host on this path, I want it sent to this service. There's something in the cluster called an ingress controller, and it listens to the Kubernetes API. And when it hears that an ingress was created, it looks at the configuration, and then it configures itself to do whatever was asked. Ingress controllers are software load balancers, Nginx, Apache if you want, HA proxy. They could be, I mean, there's a bunch of them. There's Ambassador, there's all sorts of them. They could be service meshes. Service meshes, they do a totally different thing, but most of them have ingress functionality. So they can also do ingress stuff. So that would be like Istio or Linkerd or Mesh or whatever, service meshes. API gateways like Glue and Kong, those also provide ingress functionality. Ultimately, it's just a thing that understands, oh, I'm going to receive traffic, and when it looks like this, so I'm going to send it over there. It's pretty simple. Oh, look, it's another image. I spend all this time explaining things. I should just be like, here's a slide, enjoy. Notice the ingress on the right. So host foo.bar.com, path/foo, send to service A, path/bar, send to service B. Now you're starting to get into microservices. Now you can have one thing receiving traffic for your site and directing /store over here and /profile over there and doing whatever other kind of routing that you want. So let's put an ingress in front of this. And see what we have for this. Rancherdemo.cl.monakas. Okay, so path/ path type prefix. This is our host name. We're going to send it to the service called demo, and we're going to send it on port 8080. And if you remember over here, our service is listening on 8080. Now this is a node port service. Let's fix that. By changing that to cluster IP. And this is also going to, let's just do this even faster. Delete service demo, boom, gone, k expose, deploy demo, and let's take out the type. If we just expose it without specifying a type, then it becomes a cluster IP service, which is the default. And now notice that it's only listening inside the cluster on 10.43 on port 8080. Now when we apply our ingress, Rancher-demo, let me remember that. You see we have an ingress, demo ingress, and Rancher demo. That's the address, which is also the address of demo A. And now you see that it's listening on port 80 because K3S runs an ingress controller. In this case, it's running Traffic, ingress Nginx. Ultimately, it doesn't matter. It's whichever one has the features and the functionality that you want. Let me make sure that I have this set up in DNS correctly. I don't, because I was doing, yeah, let's just change that. Okay. I interchange these names with different hosts depending on what I'm actually doing, and I had that one pointed at the wrong host. But now if we go to the browser, where we had this before, notice there's now errors because the node port is gone. But if I change this to Rancher demo, well, there you go. Now it's just a website. All right. Ankur wants to know, do we need a cloud load balancer if we have an option to use an ingress load balancer? That's a complicated question. It depends on what you want to pay for and what level of control you want. Okay, so what we just set up is, imagine we had 3 nodes. And so we've got an ingress controller and it's listening on all 3 nodes. Well, we still have the same problem of what node do we put in DNS? Do we put all 3 of them? Okay, that's great. Round robin DNS, 1 node goes away, 33% of our traffic fails. So in that case, you still need a layer 4 load balancer above your Kubernetes cluster. But it's layer 4 because it just receives traffic on port 80 and port 443 and sends it to every node in your cluster. It handles the health checking. If a node goes away, it fails it, and you're still good. You can then use one cloud load balancer for all of the sites that you run, instead of having one service load balancer per site. So back to my original statement, if you have 1,000 websites running in your cluster, well, now you just need one cloud load balancer and one ingress and a few Kubernetes nodes, and you're good. And you just save yourself $20,000 a month. Some companies like paying $20,000 a month or more. I've seen some companies' cloud bills. Holy cow. There's so many better things to do with that kind of money. So real quick, we're going to talk about config maps. Remember, this is being recorded. If it does go long, you will get a copy of the recording. Don't sweat it. It is what it is. We've all been in a situation where we are deploying something. Let's use the Nginx container that I've been playing with all day. It's an Nginx web server. It has an nginx.conf. I 100% guarantee that its nginx.conf is not what I need it to be. So how do I fix that? Do I create my own Docker file, import from, or build it off of their image and then add my config file? I could do that, but now I have to rebuild it whenever the upstream container changes. That's work. I could create an NFS server, and inside of my container, I could mount a volume with the nginx.conf in it. That would also work. Change it in one place, that's all good, but now that's more infrastructure that I have to maintain, and it's another point of failure. So maybe not. Config maps solve this problem. Config maps are a way to separate the configuration from the workload, and they become two separate resources in Kubernetes. A config map is just a map of key value pairs. So it could be a key with a single value, a key with a multi-line string, whatever. You can attach these to a workload in one of three forms. The keys can become environment variables, with the value being the value. The key can become a file name, with the value being the contents of the file, and you can replace those on a one-by-one basis. Or you can say every key becomes a file in a directory, and Kubernetes literally takes over the whole directory, and every key becomes a file with the contents becoming the contents. What's super cool about config maps is you can update them independently of restarting the workload. So if I have a config map with some environment variables or a config file or something like that, whatever, a file on the file system, and I change the config map, it just gets updated in real time in the pod. Your application still has to be able to detect that change and do something about it, but it's still like you can make changes without restarting workloads. It's pretty cool. I think it's cool. There are two schools of thought about whether or not it's cool. One school of thought says, yes, it's super awesome. The other school of thought says, well, it's less awesome because now we don't actually know the state of the pod to be able to reproduce it if it dies. So if we launched a pod and then I change the config map and then I go off on vacation again and something goes wrong, it's not obvious what the state was. So in the GitOps repeatable declarative school of thought, they actually suggest that any change to the config map does restart the workloads. And that way you can still have it in a Git repository, you know exactly what's what and where's where, and you can repeat that state. Both of them are right. It depends on which one you care more for, which one is right for you, which one is right for your environment, and what you want to do. Just know that, both exist. And if you're using a tool like Kustomize and you still want it to update things in real time, even though Kustomize by default will do the whole rolling restart of the workloads, you can disable that and you can tell it not to do that and just update stuff in place. So whatever. I only talk about config maps, but there's another thing inside of Kubernetes called a secret. And that's kind of the same thing as a config map, but Kubernetes treats it differently. So you can use secrets for secret data, passwords, API keys, things like that. Understand that by default, Kubernetes does not encrypt secrets at rest. They're base 64 encoded, but so what? Like that's not real security. It just does that so that multi-line strings become one string. You can tell your Kubernetes cluster to encrypt secrets at rest, and they will be encrypted in the database. You can also use external secret management systems like Vault or whatever, AWS Secret Manager or there's all sorts of things where you can have your cluster actually pull a secret out of some other storage and then attach that to a workload. So just know that config maps are not for secret data, but there are also secrets. I just don't talk about them in the class. Okay, let's real quick show you how we can do something with config maps and customize. And then we're going to get into Rancher. Ankur says Envoy. Yes, Envoy is, most service meshes are actually built on Envoy, which is what would you call it? It's a proxy. Envoy is very cool. Grab what I was doing. Content, terminal. There we go. Let's delete this stuff that I've got going on here. See all this deleting that I have to do? Delete ingress. What's our ingress called? Demo ingress. Wouldn't it be nice if I didn't have to do that? Where am I? Okay, the deployment that we first created. So I'm in this deployment directory. And let me show you what a customization.yaml file looks like. It says, okay, there's actually, let's not look at that one. let's erase that before you get confused. Let's look at this one. In the base directory, I have some files. I have a deployment and I have a service. And I have a directory called configs, inside of which I have a file called index.html. My deployment, we actually saw this in the beginning, and I said there's some other stuff here that you don't need to worry about. Notice down here in the volume section, I say create a volume called index from the config map called index. So let's assume that I've created a config map called index, and now I want to create a volume of the config map. And then up here, I'm saying take the volume called index, mount it at this location using this key from inside the volume. Inside that config map is going to be a key called index.html. The contents, the value of that key is going to be that HTML file that you saw. And this deployment is going to mount that at user share nginx HTML index.html, overwriting the default nginx index.html file that comes with the container. The way that happens is in this customization file, where I say resources. Just take these two files, deployment and service, and go install them. Don't change them. But before you do, make a config map called index out of that file. If I run customize build, it will show me the manifests that it's about to create. So you see there's the config map, and notice it has that, it's not just index, it's index-gobbledygook. Customize is smart. That's a hash. And down here in the deployment, it just replaced the index from the manifest with the actual name of the config map it created. So that's pretty cool. So if we run this, we would get a deployment, but we're not going to run it because I'm going to come into this overlay directory that sits one level above. Inside of here, I have two other directories called production and staging. If I show you staging's index.html, it says hello from staging. The other one said hello from nowhere. And if I show you the one for production, it says hello from production. Real quick, I'll just show you the staging. And now the customization.yaml is a little more interesting. Staging dash will be prefixed in front of every single name. Everything will get a label of environment is staging. It will start with that base directory that we were just in with the deployment and all of that stuff. And then it's going to patch it with some stuff found in this directory, which will change the image and the replica count. And then it's going to create its own config map from its own index file and use that instead. Same exact thing happens from production, the result of which is if I do kubectl apply-k production and staging and ingress single, it just created config maps, services, deployments, and an ingress for 3 different environments on one cluster. If I say kubectl get deploy, you see we have dev nginx, staging nginx, and prod nginx. Prod nginx has 3 replicas. Staging and dev only have 1. I have 3 services, prod, staging, and dev. 2 of them are node port services, and 1 is a cluster IP service. If I were to curl that one, you see hello from production. If I were to curl this one, you see, whoops, not dash I. Well, you see that it's a 200. That's nice, right? You see hello from staging. And it also created an ingress which says hello from nowhere. We were able to do all of that from the same base template file and just slight modifications for each environment. And that's just an introduction to what you can do with the tool like Kustomize to minimize the amount of work that you actually have to do and maintain the number of the opportunity for human error and so on and so forth. Okay. Anusha says, can we set config maps to trigger at a certain time period instead of applying the changes instantly? No, they're part of the configuration. So yeah, that's that. Austin says, what's the relationship between managing pods through config maps and deployments? Well, the deployment actually manages the pod. The config map just manages the contents. And I'll give you an example. Let's look at our dev environment here. So dev nginx. If I say get config map, we should have a dev index. So remember, this was that's when we curl the dev environment, that's what we get, hello from nowhere. If I edit that config map, which ordinarily I wouldn't do, actually, you know what, let's do this the right way. So I'm back in that base directory in configs. I'm going to edit index.html, and I'm going to change this to hello, Austin. And this was actually part of the ingress. So where am I? So now if I do kubectl apply -k overlay single, imagine I push that out to a Git repository and now something is pulling it from the Git repo. You'll notice that it created a new config map. The service was unchanged, the ingress was unchanged, but the deployment was configured to use the new config map. And now when I curl that, you can see that it says, hello, Austin. So config maps, you're managing the configuration inside the pod. Earlier, when I set cow color to yellow, I could have done that with a config map instead of doing it directly with the environment of the deployment. So you could have somebody responsible for the configuration of an application independent from the people who are responsible for the architecture of the application. And if somebody wants, if you can assign an intern, pick the cow color for today, and they can just change the config map, and it'll update the application, and they don't have to go and break the deployment. Okay. Wow. Rancher time. I don't actually have Rancher slides because Rancher's all just real time. So let's go and install Rancher. There are different ways that you can install Rancher. It used to be that you could install Rancher into a Kubernetes cluster, or you could run it as a Docker container. And we would say Docker container is just for lab testing environment, but if you want to actually use it in production, run it in Kubernetes because you can never go from one to the other. It also used to be that the only supported Kubernetes cluster for Rancher was either RKE or K3S. With Rancher 2.5, which was released late last year, that has changed, October, I think. You can now install Rancher into any Kubernetes cluster. And you can also run it as a Docker container and back it up and restore it into a Kubernetes cluster if you want. So you have a lot of flexibility. I prefer to run Rancher inside of Kubernetes. And the way that we do that is with a package called Helm. There are two things that you need besides Rancher itself. Well, there's one thing that you need besides Rancher itself. One is the cert manager chart. Cert manager manages SSL certificates for a Kubernetes cluster. And the second is Rancher itself. So I would run Helm repo add jetstack, and I would add the jetstack repo. And then I would say Helm repo add, I'll explain what Helm is in a second. I want to get this installation actually started. I would install Rancher. And then I would run Helm repo update. And that would go out and pull down the latest charts for the packages that we want to install. With that, we're going to install Cert Manager. While this installs, I'll tell you what Helm is. Helm is the package manager for Kubernetes. You can think of it like RPM or Yum or apt or emerge or whatever. Those things exist and you understand them. Like rather than saying, once again, if you remember, we used to actually go pull down source code and compile it and then install the applications. And then somebody was like, this is stupid. Let's just create packages. Kind of the same thing. Like I could give you a bunch of manifests and be like, install this and open a node port and change this value to whatever. And that's bleh. So instead, we create packages. We make them available in a repository that functions like a special Git repository, and then people can install from the package. You can override certain values. For example, I can set install CRD is equal true, and then the package will adapt and it will do certain things based on what I need for my environment within a range of defaults. Let's see if that installed. That's almost done. Okay, that is now ready. So we can say Helm install Rancher. Rancher training, set, create namespace. Yes, good. Helm install Rancher. That's what we're going to call it. It is the Rancher chart in the Rancher stable repo. We want it to go into the cattle system namespace. I'll tell you about namespaces in a second. We want to set the host name to ranchertraining.cl.monachus, and we want to set the Rancher image tag to 2.5.5, and I want it to actually create the namespace. I chose to set the image tag because I live in South America and because everything is really far away. I know that everything for 2.5.5 is actually on my caching server. The current stable version, I think, is 2.5.6. I just haven't updated the cache. A namespace in Kubernetes is a logical grouping of resources. Once again, this will make sense. You can't have two deployments called Nginx because how does Kubernetes know which one you want to talk to? But what you can have is, well, let's say two deployments called website, since it makes the example easier. You could have a namespace called production and a namespace called staging. Inside of each of them, you could have a deployment called website. So namespaces become the boundary for naming of resources in Kubernetes, and they're also the boundary at which you start to apply role-based access control. So when you get into configuring who is allowed to do what in your Kubernetes cluster, namespaces are the boundary at which those things are defined. So you could have a production namespace that only SREs have access to, but a development namespace that developers have access to, or you can break it up by team, or you can carve up your cluster however you want. How's this doing? Okay, this is okay, get PO-N. So you see when I want to talk to a namespace, I'm passing cattle system or cert manager or whatever the namespace is. So this is showing me the pods that are in cattle system versus the pods that are in cert manager versus the pods that are just in the default namespace, which is actually called default. So while these finish building themselves, let me see if we have any questions. Oh, we do. That's exciting. Philippe wants to know, can config maps add and remove files like themes for a CMS? Yes and no. If you had the file in the config map, then yeah, totally. Just remove it from the config map and don't worry about that error. That'll fix itself. You just remove it from the config map and it'll get removed from the systems. It's not the best way to do something like themes for a CMS. It's better really for configuration files. If you wanted to do it for, yeah, if you want to manage files, there are other ways, better ways to do it than to use a config map. But you could, if it's text content, absolutely. Parth wants to know, I'm not wearing my glasses, I want to make sure that I said your name right. Can we use GitOps with Rancher to ensure that new clusters are consistent with each other? Yes, that's exactly why you want to use GitOps, is to make sure that you build a new cluster, pulls everything down, and then you go from there. Let's see what's going on here. Not sure why that last one's complaining, but we'll let this continue. Philippe says, do you recommend Rancher D or not recommended yet? I don't personally recommend Rancher D just because it's not generally available. It's still something that's under development. So it's something that you could use and play with just as long as you understand that it's under development. So it might not work. It might work today and not work on the next release, or just because it's still under development. Specifically, you're asking about the Rancher D method for installing Rancher. I have not tried that. You're the second person I've seen mention that. I just go with Helm. You see that it's installing a bunch of other stuff, and I stick with what I know. How can you use a Helm chart with a config map? Helm charts bundle Kubernetes resources into a package. So you can have a config map in your Helm package, and then you can have -- set whatever, you can set values when you install the chart. And in the config map, there would be placeholders with variable names, and those would be replaced with the values that you set when you installed the chart. You can either set things on the command line like you saw me do, or Helm, also all Helm charts come with a default set of values called values.yaml. And if you have to change a lot of different things, you can just change those and just give it a file that has all of the YAML for all of the stuff that you want to change. Ooh, more questions. Part says, considering that Rancher doesn't have its own registry, can we use corporate Artifactory or ECR as a registry with Rancher, or do we need to set up a private repo? Yeah, you can use any registry you want, public, private, whatever. You can configure it from inside of Rancher, or you can depending on what your Kubernetes cluster is, you can set the cluster to pull from something. So you can see here, I told you I have a cache in the house. It's Nexus. It's a Sonatype Nexus. And here I'm telling it use my local cache for everything. So everything gets pulled through the cache. I could say use the cache for some stuff or not other stuff or whatever. If this is configured at the Kubernetes level, then Kubernetes will use it for everything. But then additionally, within Rancher, I could provide credentials for a private repo, for example. And then when I put the full path for those container images, they'll be pulled from the private repo. So Rancher should be up now. We'll come back to the rest of the questions in a second. Yes. Oh, self-signed certificate. Oh my gosh. Ah, so scary. When you first log in, you will be asked to create a password, and then you tell it whether you want to use Rancher just in the local cluster, or if you want to use Rancher to manage lots of clusters. It doesn't change anything other than the default view that you see when you log in. I'm going to tell it that I just want to use Rancher to manage this cluster, and then we'll continue. We will be taken to the Rancher dashboard UI. There's a lot here. you already learned everything about how to do stuff with Kubernetes, so I can show you that part really quickly and then just talk about the additional functionality that Rancher provides. But because this is an intro to Kubernetes and Rancher course, I gloss over a lot of this stuff because it's if you want more specific Rancher deep training, I'll show you where to get that at the end. So cluster dashboard, this tells us a lot about what's going on in our cluster. We have one node, 54 total or 51 total resources, so on and so forth. Over here in the left menu, you can see we can get more information about the nodes themselves. So we only actually have one right now. And then under workloads, you see that it's already picked up the workloads that, the workloads that we installed before. So if we go to dev nginx, it's going to tell us that this was not actually installed by Rancher. So, there's not much that it wants to do with it. But if I click on YAML, you can see all of the YAML that's here. And this is all editable. So if I were to change replicas, for example, oh, sorry, it's not editable. Now it's editable. If I were to change replicas to 3 and then save, well, then it'll actually go and update it, and it'll give us 3 replicas, and it'll do everything. The objective of Rancher is to get you to a running state as quickly as possible and to kind of be your wingman, like to help you do things more quickly and to fill in the gaps in your Kubernetes knowledge by giving you some nice structure, but not hiding any of Kubernetes from you, so that if you want to dive into the YAML or go behind the scenes, all of it is there for you. So for example, we could come up here and we could do a deployment. So if I were to say create, let's call this demo. Image is going to be Monachus Rancher demo. We'll add port 8080. We will give the variable cow color is yellow because we know that works. We're going to label the pod app is demo, and we'll say create. So we have a pod running demo. So you see how much faster that was than actually doing the YAML? Now I can edit this via YAML, or I could edit it via the config. So if I come in here and I change replicas to 3, for example, then I can say save, and it's going to go and do an update. Because I specified a port, it went ahead and created a service for us. So app is nginx. Oops, that's the wrong one. Oh, it didn't create a service for us. That's interesting. It should have. Okay, well, that's not a problem. Let's just go ahead and create our service ourselves then. So create cluster IP service demo selector key app equals demo. So remember, we labeled it app equals demo. Now we're going to create, oh, we have to tell it a port. Listening port, let's put that on 80, target port 8080, and say create. Okay, so now we've got that. So that's working, selectors app equals demo. And now we could come over to an ingress. There's our dev demo ingress, you already saw that. So let's create a new one. And actually, you know what, let's just hijack that one. Let's edit it. And target service is going to be demo, and port is 80. And we'll say save. And now, so remember before it said, hello, Austin? Well, now, whoops, demo A. Huh, there you go. Acceleration, ease of use, form-based stuff, but then it starts to get cool. So here, every single Kubernetes resource that you could possibly imagine, you can go and look at and configure. There's even more down here under more resources. This is where you'll find literally everything that Kubernetes has. Here's our config maps, for example, that were created. Secrets, persistent volume claims for storage. But let's talk about multi-cluster functionality and then let's talk about apps and GitOps. I'm trying to do all of that in the next 10 minutes. Rancher 2.5 has a transitional user interface. What that means is everything used to look like this in Rancher 2.4. In Rancher 2.5, the single cluster dashboard UI changed, and in Rancher 2.6, the multi-cluster dashboard is also going to change. So we updated one. The old one is still here for multi-cluster stuff, but an update is coming. So it is what it is. If you find yourself stuck in this view, you can just click on Explorer, and it will take you back into the Cluster Explorer view. And then we got out of that by, you can't see my mouse, but by clicking Cluster Manager up there in the top. So with that, this is the old cluster view. And you can see up here, there's Cluster Explorer if you wanted to jump out. But let's go to the global view, and say Add Cluster. If you want to use Rancher for multi-cluster management, you have lots of options available. You can bring up a hosted Kubernetes provider. There's 3 of them that are enabled by default. There's a bunch more drivers that are just not enabled. So this will reach out to the cloud provider, spin up EKS or AKS, do all of its configuration, and then wire it back into Rancher so that you can manage it from within Rancher. The next line is about infrastructure. In this case, instead of a hosted Kubernetes cluster, you can spin up infrastructure nodes. It'll spin up EC2 nodes or Azure or GCP or whatever, and then it will install Docker, deploy RKE, build Kubernetes, wire it back into the Rancher server, and you can continue to manage it from there. If you have existing nodes that you provisioned with Terraform or whatever, shell scripts, autoscaling groups, all it needs is a supported version of Docker. We will give you a Docker run command to run on those nodes to build a Kubernetes cluster. You can incorporate that into your provisioning system so that in the future, when you bring up more nodes, it can automatically run that command and it can automatically join the cluster. This is great for autoscaling groups. You scale the group up, the cluster grows, you scale it down, the cluster shrinks. And then if you already have a Kubernetes cluster that you've built via any other means, you can import it into Rancher. This other cluster option is for all Kubernetes clusters, whatever they are. And EKS is special. In 2.6, we will have that same specialness for GKE and AKS as well. But what this allows is you can import an existing EKS cluster, and we will take it over as if we had deployed it. So you can do upgrades, you can do lifecycle management of the resources inside of it, not just the workloads, but the cluster itself for existing EKS clusters that you already have. Also out at the global level, we have security. You plug Rancher into backend APIs, backend identity providers, and we will bring down those users and groups and enable them for global level access control to all of the clusters that Rancher is managing. So now it doesn't matter where your cluster is. You don't have to configure IAM privileges or GCP privileges or any of that stuff. You just give people access to Rancher. So if you have Active Directory, somebody joins the organization, you put them in the team, they immediately get access to the clusters that that team has access to. They would log into Rancher, they would go to that cluster, they would click this kubeconfig file up here, they would get a kubeconfig that uses Rancher as an authentication proxy for downstream clusters. And then when they leave the organization, if they should, you just disable their account in Active Directory, they lose access to everything. You don't have to worry about what do they have access to? Did I get it all? Or is there going to be a data breach? None of that. Rancher has that taken care of for you. You can also do the same thing with local users and groups if you want. Back here in the cluster itself, up here in the top corner, we have 2 other options, Apps and Marketplace and Continuous Delivery. Apps and Marketplace, these are Helm charts. There are 2 types that are here by default. Blue ones are Rancher apps. So we have CIS benchmark for security scanning of your clusters. Istio, logging operator, Rancher backups. This is how you would export out from a Docker container version of Rancher and import it into a cluster, Kubernetes cluster version of Rancher. OPA gatekeeper, monitoring, Longhorn, and the green ones are from partners of ours. But you can also add any external Helm repository. And let's get Kyverno just as an example. Where are you? There we go. So we'll paste that, say create, and boom, it's now updated the Kyverno repo. And if I come back out here, you'll see down at the bottom, Kyverno is now available for me to install into my cluster. Kyverno is a policy management suite similar to OPA Gatekeeper, allows you to control what happens when people apply resources to your cluster. It's very cool. So you could do this for anything, and then you can deploy stuff here, and it's exactly the same as if you were to deploy it from Helm. Remember I talked about values.yaml? So here's the default values.yaml from Kyverno, and I could change these things as I see fit for my environment before saying install and having it go and install it in the cluster. The last thing that I want to talk to you about is continuous delivery. This is GitOps. And then I'm going to try and do this in the next 4 minutes. And then I know there's a bunch of questions. I'm going to stay until the questions are answered. If you have to leave, this is being recorded in 2 places now. And you'll get a copy of the video later. But we're here. We're in it. Let's keep going. The first thing I'm going to do is I'm going to go and delete all of the stuff that I created. No, that's not what I wanted. So these are 2 deployments. How's that, huh? I just deleted 3 applications with a single command. This customization file, as you see, told it to go and pull whatever was in these various overlay directories, which are the directories from which we installed before. And with a single command, kubectl delete -k, telling it to use customization and pointing it at the directory with the file, gone. The last one is the demo that I created. Let's go delete that one from inside of Rancher though. So we'll come back over here to Cluster Explorer. I'll go down to my deployments and we'll just delete that one and come down to services and we'll delete that one. You see why customization is cooler? And ingresses, and the ingress was part of the other one, so it's already been deleted. Okay. Now, I tried this last week and it failed on me, and I'm hoping it doesn't fail on me this week because the week before it worked. So, continuous delivery. This is done by a product called Rancher Fleet, which is a GitOps solution. Rancher Fleet is designed to do GitOps for up to 1 million Kubernetes clusters. And every time I say that, everybody's like, what? Like, who in their right mind would ever have 1 million Kubernetes clusters? It's easy. Remember, at some point during this class, I told you the reason you need to learn Kubernetes is because it's what the future is. 1 million clusters is easy. Every ATM, every vehicle, like Tesla's already they all phone home and do firmware updates over the air and stuff like that. Kubernetes, they have Kubernetes running on U2 planes. Every streetlight in a smart city, all of the edge environments are going to be running Kubernetes nodes because of things like GitOps and because of the orchestration functionality of Kubernetes, making it easy to maintain all of that stuff and push deployments out across whole fleets of systems. Hence, Fleet. So Fleet, I'm going to put it in the local cluster. There's 2 workspaces. Fleet Local is for Fleet work in the local cluster. That's the cluster where Rancher is installed. Fleet Default is the default workspace for other clusters that Rancher is managing. In this case, Rancher is only managing itself, so we're going to switch this to Fleet Local. And we're going to call this demo. And I'm going to point this at our Git repo, github.com, Rancher case intro training. And I'm going to add a path of 02-deployment. So I'm telling it, go to this Git repo and then go to this path, which is the same path that I used a second ago with that customization.yaml file in it. Go to that path and that's it, and do what's there. We'll say create. We'll see if this works. The reason that it didn't work before, okay, that looks promising. If I click on that, Okay. Didn't give me an error yet. Nodes ready 1, fleet local, name, demo. You gonna do something though? There's this weird Kubernetes DNS thing related to Alpine containers and how Kubernetes goes through the DNS domain searches. Oh, oh, we got a change. It says wait applied. Oh, this is very exciting. Oh, it deployed. Oh. Oh, that's great. I'm so glad that worked because there's still 123 people watching. Okay, let's jump back over here. Let's go to our deployments. And all of those things that I deleted before just got reinstalled because it's using the exact same customization file. When I was doing the customization stuff, I know some of you were like, why are you talking about this? This is really advanced. It's so I could show you this. So this is GitOps in play. This has everything. So it created the same services. Let's go look at our services. So it created the same services on cluster IPs. So you got the 2 node port services there. It created the dev one, and then it went and created an ingress for dev demo ingress up here. And if I click on that, no, that's probably not an SD host. Hang on. Terminal. Rancher training. Really? Oh, training dash A. Oh, that's an error on my part. The host demo A used to be called training A. So somewhere in there, let's actually, okay, we're going to use this. We're going to use this. I have an error in my code somewhere. So let's go find that, fix it, commit, push, and it's going to automatically update. And that's GitOps. And then we'll go to questions. Yep, there it is. It's in overlay ingress fan out. Oh, that's interesting. It shows fan out. Why did you choose fan out? Okay, well, let's change that to demo A. I'm going to save that, but it shouldn't have overlay ingress, AI customization. No, cat customization. No, overlay ingress single. That's really interesting. I'm not sure why it picked that. It actually installed, like the only place that exists is in a different file that it shouldn't have installed. CD overlay CD ingress single. That's cat ingress cat. Oh, I know why. I know why. I know why. Get status because no. That's why. Because the copy that's out in the Git repo is not updated. Git commit -m update hostname git push. Okay. And now we're going to come back over here to the browser, and we're going to come back out here to continuous delivery. And what was our commit? So EA49946 was our, oh yeah, it's already updated right there. EA449946, EA, yeah, whatever. So now if we were to come back to Cluster Explorer, show you my ingresses, they've already updated because it's an ingress. Oh, actually, no, it didn't yet. Not sure if that's going to change. Boom, changed. Demo A. Did you see that? It said training A a second ago. So it brought it down, it refreshed it, and now if we go to demo A, hello class, this is the default environment. GitOps. There you go. All right. 5 minutes till. Oh my gosh, there's like this many questions. We'll start from the top. Paul says you're installing Rancher into Kubernetes to make it HA. That is correct. Even though I have a one node Kubernetes cluster, I could turn it's harder with K3s. I didn't deploy this with etcd. I deployed it to be a single node cluster. Had I deployed this as a single node cluster with etcd, I could have added 2 more nodes and it would have become HA. Rancher uses Kubernetes. So if Kubernetes is HA, Rancher is HA. That's why. James wants to know, can Helm Rancher be configured in Git instead of CLI? Yes, absolutely. There is, let's see if I have something I can show you with this. There is workspace, Monachus, cncn.io, no, channel resources, 121.02, Rancher. Check that out. K3s has what's called a Helm controller inside of it. So instead of doing Helm install on the command line, you can actually create a manifest. So here we have a Helm chart manifest for Rancher that says install the Rancher chart in the cattle system namespace from this repository and use these values, which are the exact same values that you saw me use with --set. I could take this and put it in a directory on the node that K3s watches, and any manifest that you put there gets installed. So you could just drop manifests in there via however means you want, and they'll get installed. Super cool. Can you tell that I'm excited? Can you tell that I love Rancher? I love Rancher. What's the difference between RKE and RKE2? This is a question from Anusha. Which is recommended for high availability? And can we build Kubernetes or Rancher up to PCI standards? Ooh. Kubernetes on PCI is a much more complicated topic than I can get into in this class, but just know that there are PCI compliant Kubernetes environments. There's in fact, I don't remember their name. There's a company who makes an open source Kubernetes distribution specifically to be PCI compliant. Yeah, okay, so I'm not going to find it quickly, but there is compliant Kubernetes. Look at that. Compliant Kubernetes. This is PCI compliant Kubernetes. So you could deploy this and then import it into Rancher and still run it with Rancher, and your environment would be PCI compliant. Now you get into like what access does it have? Like Rancher can do all sorts of stuff, as can Kubernetes. So you can have an air-gapped environment with Rancher installed on it and not accessible to anything outside, and you can still use Rancher, when you're sitting next to the computers in the data center, actually talking to it. As far as the difference between RKE and RKE2, RKE is based on Docker, because remember, Docker's been around forever. And even though the container runtime of Docker is now containerd, like Docker is Docker. It's been around forever. So RKE has also been around for quite a while. It's very mature. It runs all of Kubernetes in Docker containers. But now, today, you've got containerd, cryo, other security stuff that's for that. At the moment, RKE and RKE2 are being developed in parallel because they're different. At some point in the future, you're going to see all of the features that are in RKE move up to RKE2 so that they have feature parity. But because we sell support contracts and we have customers on long-term support for RKE, RKE is going to be around forever. There's no reason to switch from one to the other today. If you asked me which one to deploy today, unless you need FIPS 140 compliance, I would say stick with RKE because it's more mature and it has a lot more configuration flexibility and stuff. If you're thinking, oh, Docker, Kubernetes, and that whole thing, the Kubernetes support for Docker it's not going to be a big deal. The Docker shim, which is the thing that they want to deprecate support for, is support for that's being picked up by Mirantis. So you'll still be able to get full support for RKE, Kubernetes, Docker, all of that stuff. RKE is part of our supported configuration. Therefore, we will continue to make sure that it works. James, should Rancher be in its own cluster or can it be in the same cluster as a production website? That's up to you. If you only have a single Kubernetes cluster, put Rancher on it, use Rancher to manage it. As soon as you want to use Rancher to manage other Kubernetes clusters, then we recommend that you have it on its own cluster because it needs extra resources. It needs 8 gigs of RAM per node. Just the more clusters it's managing, the more it has going on. And you don't want Rancher causing your production website to go down if it suddenly gets busy talking to some cluster somewhere that's freaking out. Can you talk about installing Rancher first and then deploying Kubernetes nodes in a vSphere environment? I don't use VMware. Let's see. Talk about installing Rancher first and then deploying Kubernetes nodes on a vSphere environment. Okay, I will try, do my best. We're going to come back out here to Rancher. We're going to go out here to Cluster Manager. We're going to go to Global. Now imagine this is a Kubernetes cluster on a VM that I deployed in a VMware environment. So it could be a standalone K3s cluster, just like we did on a VM. I'm just using Proxmox instead of VMware. I say add cluster, and I'm going to come down here to vSphere. And here, here's where I become useless. So you build out node pools. So you say, I want these nodes of this kind for running etcd, these nodes of these kind for running the control plane, and you give it some additional stuff around RKE. And it will, so I'm not sure at what point you need to give it access to the vSphere environment, but it will go out and talk to vCenter, and it will do all of the same provisioning of infrastructure and installing Docker and everything that it does for the cloud. If you want to know more about that, join the Rancher user Slack. There's a whole vSphere channel there of people who use VMware. Does RKE Gov need to be installed on a Kubernetes cluster? It seems to indicate it has Kubernetes built in. RKE2 and RKE Gov are the same thing. It's the same thing. And you're correct. It ships with containerd. So you just need to run it and it installs itself. Coronakar asks what version of Rancher this is. This was Rancher 2.5.5. Can't see it, but it's down there at the bottom. Austin wants to know if K3OS is a different use case than Rancher OS, or is K3OS replacing Rancher OS? It's complicated. Once upon a time, there was Rancher OS. Rancher OS was a container-based operating system that competed with CoreOS. Everything ran as Docker containers. You had system Docker and you had user Docker, and even all the system level stuff was Docker containers. It's great, except that now we have other things. So Rancher OS being tied to Docker means we needed to do something else. K3OS was the first thing that we were doing. K3OS is an operating system that is immutable and managed from within Kubernetes. So you would deploy K3OS, it comes with K3s, and you can do, I don't know if it's correct to say that it was immutable or if it's just that you can manage stuff within it. I don't know if you're also dealing with the immutable partitions and stuff because I haven't used it. But the idea was that you wouldn't ever have to log into the node to make changes on the node. You can manage the state of the node using Kubernetes resources, custom resources. So you could update kernels, reboot things, you can do all of your stuff. But that's also evolving. So today, I would say don't run Rancher OS. I would also say you can run K3OS, but understand that it's still under development. And remember that still under development means possibly going to change in the future. That's all I can say. Andre says, is it possible to save Helm repo deploys locally to Rancher? I'm not sure I understand that question. I showed you the Helm chart manifest thing. That might have answered your question. If not, ask the question differently, and I'll try to answer it again. Anusha, is Rancher integrated with HashiCorp Vault to access any secrets that it needs? Rancher is a solution for managing Kubernetes. So Rancher itself, let's go to Apps and Marketplace. Rancher itself doesn't need to integrate with HashiCorp Vault. Kubernetes does. So you can deploy the secrets interface for Vault in your Kubernetes cluster, and the secrets that you then go and deploy from your workloads, like you just need to, you would need to say whatever the syntax is for where to go and get the secret, and the Kubernetes operator that handles that integration is responsible for doing it. Pablo, excellent question. Do I have to pay to use Rancher? You do not. Everything that Rancher does is 100% free and open source. Free as in free, not free as in you pay, you get extra features. 100% free. We do sell an enterprise subscription, essentially a support contract for companies who want access to engineering resources, priority support for solving issues, for developing features in the product, for all of those things that an enterprise needs. But if you don't need it, you don't need to buy it. Everything is free. Go crazy. Philippe says Cluster Explorer is eventually going to replace the Cluster Manager. It's yes and no. The Cluster Manager will look like Cluster Explorer. One of them is written in Ember, the other one's written in Vue. I don't remember which one's which, but it's not going to continue looking like this. It's going to start looking like that. And we're also changing the UI in 2.6 based on feedback of the overall user experience, but it's this general look and feel. Andre says, if I keep third-party helms locally, is an option, is it possible to combine with local container repo, for example, Bastion? If I keep third-party helms locally, is it possible to combine with local container repo, for example, a Bastion host? Let me think about what's locally is possible to combine. Okay, so if you keep third-party Helm charts yourself, like if you have your own Helm charts, I'm trying to make sure I understand this. If you have your own Helm charts, can you combine it with a local container repo, for example, a Bastion host? I'm going to try and answer it. I don't totally understand the question, but I'm imagining that you've either pulled down a Helm chart or you have your own Helm chart. Either way, it's the same thing. Within a Helm chart, let's go look at Kyverno. So let's go to values.yaml, and one of the items that's going to be in here is the image repository, and so you should Kyverno, and doesn't have a tag. Okay, and the init image. So imagine that you had your own special version of Kyverno that they released just for you, and you had it in your own private container registry in your environment. You would just edit values.yaml and you would point it to your repo. Now here you see pull secrets, and this is blank. Back in the cluster, if we come down to secrets, this is what you would do if you had a private Docker registry that needed credentials. So you come over here to registry, and you would put in whether it's Docker Hub, Quay, Artifactory, or custom. Custom means anything else. And so registry.andre.com, and it would be Andre and whatever your super secret password is. And then you would save that. Oh, name. Andre registry. And let's put this in the right namespace. And we'll say save. Okay, so now we have this secret here, Andre registry. And back in the Helm chart, apps and marketplace, Kyverno, values.yaml, scroll down, we would put the pull secret here. And then it would use that to go and pull the container images. Hope that answered your question. James wants to know, should we use customization or Helm for defining our own apps? That is also up to you. If your apps are reasonably complicated where you need to have this kind of configuration, like if they install Prometheus and there are a whole bunch of different things together where you need to change stuff, then it might make sense to use a Helm chart. So I don't use Helm charts. I use customization because I'm the only one who's deploying my apps. If you're taking your app and you want to make it available for other people to use, a Helm chart is a lot easier to use. It's the industry standard for package management. And so Yeah, I think if I was going to take my own apps and make them publicly available, I would convert them to Helm charts. Now, the continuous delivery out here, the thing that we did, it just happens to use customize, but this also works with regular manifests and Helm charts. If that repo that we pointed to had a Helm chart repo inside of it, Fleet doesn't care. Fleet's like, cool, it's Helm, I'll deploy it. And in fact, what Fleet does is it takes whatever's in that repo and it converts it into a Helm chart. It literally builds a Helm chart on the fly, and it sends a Helm chart to all the downstream clusters. Because Helm, it's the industry standard. It's understood everywhere. So the provisions for deploying workloads via Helm in a downstream cluster are well established and stable. So Fleet converts it and then sends it. Andre wants to know if Submariner is part of Rancher's supported apps. Submariner is an open source project, and it is not part of our support agreement, but it's out there, and you can use it, but you can't get support for it. Support would be community support. Submariner is a cool thing that builds a tunnel between Kubernetes clusters, so you can have stuff on the back end able to communicate with each other without traversing the internet. Andre asks if I can share the GitOps lab to try it out. It's the same repo. I literally just pointed it at the directory 02-deployment, and it saw the customization file and it installed it. You can do it yourself. Jigish wants to know, can we transfer our old 1.6 Rancher projects to 2.5? No, 1.6 is cattle, and cattle is not Kubernetes. So what you'll have to do is build a Kubernetes cluster and then treat it like a data center migration. Build a Kubernetes cluster over here, and then take your workloads for whatever it is, one app at a time, and turn it into a Kubernetes app and deploy it over here, test it. When you know that it works, repoint your IPs. And one at a time, you're gonna have to move your apps over. I did a cattle 1.6 to Kubernetes migration. It's doable, it's work, but it's doable. Just do it one app at a time. Oh, we lost audio around the difference between RKE and RKE2. Okay, I'll say it again. RKE is based on Docker containers. So, well, yeah, so it's based on Docker containers. RKE2 includes containerd. That's probably why somebody asked the question again about if it included containerd. So to deploy RKE, you need some hosts with Docker installed. And then on your local machine, you run RKE up. And it uses a local config file that you build to, it SSHs out into the nodes, and then it builds the Kubernetes cluster on all of the nodes using Docker containers, and it wires them all together. RKE2, also known as RKE Gov, you actually go out to the node and you pull down the RKE2 binary and you basically run it, and it builds a Kubernetes cluster with containerd, and it has everything bundled into the binary. Same with K3s, just K3s is smaller. So it's an all-in-one solution. What's missing, the primary thing that's missing between RKE and RKE2 is that local config file. In RKE, I can change my local config file and say RKE up, and it'll SSH out to the clusters and redo it. So I can have like a one node Kubernetes cluster, and then I can add two more nodes in RKE, run RKE up, and it'll go out and it'll build two more nodes and wire them together. I can delete two of those nodes, run RKE up, it'll go out, delete two of those nodes, and turn it back into a one node Kubernetes cluster. RKE2 doesn't have that central config file. I don't know if it's going to have it, but it's just one of the things it doesn't have right now. So there's a little more work to do in getting it set up and making sure that your hosts are configured correctly so that they're working together. Yes, there will be a recording. Answered that question. Does Rancher have built-in local Helm repo option? Sure. This was from Andre again. Hello, Andre. So back here in apps and marketplace, under chart repositories, you just add a repo out there, or you can actually remember that manifest that I showed you that was the Helm chart? You can actually just apply that directly to the cluster. So if I went to Cluster Explorer, workload overview, let's see, if I say create, no, that's a deployment. Not sure where it is, but there should be somewhere there's a thing where I can actually like import YAML. So I could drop that Helm chart YAML onto the cluster through Rancher and it'll just deploy it. James, yes. Does Fleet support custom Helm charts and Git repositories via that, either the Helm chart manifest or, yeah, just if it's a Helm repo, doesn't care. James asks again, if you wanted to deploy immediately after deploying a build, would you call APIs via kubectl or would you automatically update the Git repository? If you're using GitOps, if you're using Fleet against a Git repository, then you want to make sure that the Git repository is the source of truth. If I deploy from a Git repository, but then I change it locally, Fleet's actually gonna overwrite it from the repo. It keeps a local copy of it, and periodically it goes around and it's like, oh, this is different, and then it reverts it. And I can show you that if I were to come over to this config map. Let's see, what do we have? We had Rancher, yeah, demo A, hello from nowhere. That was it, right? Yeah. So if I come into this config map and demo config, nope, that's not what I wanted. Really? YAML, indexed HTML, namespace default. It's one of these. 26 minutes is probably this one. Edit config. Hello from everywhere. And say save. No, that wasn't it. Well, we're way over. So theoretically, I could change one of these things and Fleet would come along and it would undo the change. So you want to update via the Git repository. Oxiel says, can we monitor our clusters with Rancher? Yeah, so specifically about alerting about nodes failing or pods or containers failing. Yes, what you want to install is over here. There's a couple of things. You got logging. So this installs the Bitnami logging operator. And so you can use this to log everything that's going on with the cluster. And then you want to install Rancher monitoring. And this will give you information about the nodes, the cluster, etcd, the workloads. It's crazy. When you install stuff like this, it actually shows up over here in the left-hand menu. So there'll be a whole monitoring tab and you can do additional configuration there. Randy asks, are there documents or demos around deploying Rancher into AWS serverless to run all of your clusters serverless? You cannot do that because Rancher is an application that runs in a Kubernetes cluster. So even if you run it in a Docker container, it still builds like a Docker Kubernetes cluster that then runs everything. There's no serverless functionality for it. Does Pull Secrets support AWS ECR credentials? They're only valid for 12 hours and need AWS API keys to generate. Yes. I don't know where it is here to show it to you, but there's a thing that you can install. We did it with Rancher 2.4. There's a thing that you can install that will automatically update those keys so that the keys that Rancher has are constantly up to date. Nick asks, when creating a new cluster from existing servers inside the Rancher UI, the software generates a Docker run command to set up the Rancher agent and deploy things. Considering that Docker is probably going away, will Rancher have a similar command generation feature to autostart a node with K3s? Docker's not going away. It's not going away. People think it is. Docker just got $23 million in funding yesterday or the day before. So it's going nowhere. I had this as a link this morning. Yeah, there you go. So this was on TechCrunch. People saw Kubernetes they were deprecating Docker and they're like, oh, it's the end of Docker. And I even thought the same thing. But Docker is more than a container runtime. It's a container runtime, an orchestration system, a networking component, a build component, and a fifth thing that I can never remember. So the container runtime is actually containerd. The orchestration is Docker Swarm. Or you can get it with Kubernetes. They're late to the game. Build kit is their build engine. The networking component allows you to build out different networks that your Docker can communicate on. The only thing that Kubernetes needs is containerd, but Docker sits in the way of talking directly to containerd as a CRI. It's not CRI compliant, container runtime interface. So there was this thing called Docker shim that bridged through Docker to the CRI, and Kubernetes finally just got sick of it, and they're like, we're just not going to support this anymore. And everybody freaked out. Mirantis, who are the ones that bought most of Docker's enterprise, well, all of Docker's enterprise functionality, they bought most of their intellectual property, they immediately stepped in and said, yeah, we'll just continue to support it, so don't worry about it. So what it means is it's coming out of the Kubernetes core. The core Kubernetes code will not have Docker shim in it. But there's lots of things that aren't in the core Kubernetes core, like all cloud provider drivers. Those are called out-of-tree drivers that get added back in. So if you still want to run Kubernetes on Docker, you just need to install Mirantis's Docker shim as an out-of-tree driver, and you'll be totally fine. So it's fine. But to answer your actual question, we know that that is an issue. We are working on making a way that you can deploy RKE2 or K3S or whatever. Right now, if you were to import a K3S cluster into Rancher, so we installed Rancher into it. Let's come out to Cluster Manager. And Rancher effectively imported its own cluster. And you can see here that it knows it's K3S. Any other Kubernetes cluster, it'll just show as imported, but K3S is special. We can now do stuff like, say, edit, and we can come in here and we can actually change the Kubernetes version. And so Rancher has absorbed it, and we could do an upgrade of K3S from within Rancher. So even though it's an imported cluster, you can do stuff. As far as being able to deploy it, probably it'll just be SSH install and then wire it back in, and then you'll get all of the same functionality. I don't know when, but it's absolutely in the pipe. Okay, last question. Wow, we're long class today. This is from Randy. One issue we had with Rancher 1.6 has been when a series of nodes gets replaced, we end up seeing containers getting deployed unevenly. E.g., we would have 3 nodes, do a rolling update. Rancher at some point ends up deploying all 3 containers on a single node. Okay. Yeah. So Rancher 1.6 is cattle. Kubernetes. So he's asking if Rancher 2 addresses this issue. It's not actually a Rancher issue. It's an orchestration issue. Kubernetes addresses this. You can do a thing called pod anti-affinity. So you can do affinity and anti-affinity, basically say, it's how you can control where something should go. So earlier I used an example of, a node has SSD disks on it, so you want your database pods to go there. So you would label it saying SSD disks true or something like that. And then when you deploy your workload, you would say, prefer a node with this value. And I mean, it's kind of a bad example because once it's on a local disk, it actually has to stay there. But let's just pretend. So you say prefer a node that has this value. Maybe it has a GPU. That's a better example. So prefer a node that has a GPU because I run GPU workloads. But if there's no node that has a GPU, well, if it's important enough, you should still put it somewhere. So that's node affinity and anti-affinity. Don't run this on a node with this label, period, forever, because the world will end. You can also do the same thing with pods. Don't run this pod on a node that has a pod that has this label. So now your pods from the same workload all have the same label. So if the label is like app is nginx, well, you can say don't run this on a node that has a pod with the label app is nginx. First pod goes to a node, there's no pod there, it gets assigned. Second pod, when Kubernetes is deciding where to put it, it says, can I go here? No, I can't. And so it puts it there. And then the next one, it's like, no, no, yes. And that's how you can spread your pods around. If you truly want 1 pod per node, then what you also can use is called a daemon set. Today, we only worked with deployments. And a deployment is for stateless applications like HTTP. Stateless. Doesn't know who you are, doesn't care. You can go away, you can come back. It's like, hey, it's nice to see you. I'm Tom. There's also a stateful set, which is where you need stateful workloads. Use these for databases. It matters who the master is. It matters where the slaves are. It matters what their addresses are. It matters what their names are because they have to find each other. That's a stateful set. The daemon set will run 1 pod on each node. So if you have 3 nodes, you just fire off a daemon set, you get 3 replicas, 1 on each node. If you add a fourth node, it automatically gets a pod assigned to it. Now, if you add 100 nodes, you're going to get 100 pods. So if you don't want that, then just use a deployment with replicas of the number that you want, and then pod anti-affinity to make sure that they're not all stacked up on the same thing. Woo. Okay, we almost done? I'm starting to lose my voice. James says thank you, and that Kubernetes and Rancher is a lot less daunting. That's what I want out of this class. I want you guys to go away from this being like, holy cow, this is so much fun. Because if we're not doing stuff that's fun, then what's the point of doing anything at all? Oxiel, let's say I install SUSE or CentOS with Docker and Kubernetes from their repos. Okay, can I import and manage them with Rancher, or is there a criteria to meet in order to achieve it? Every single distribution of Linux has its own special flavor of Docker that does its own special stupid thing that will eventually bite you. Our recommendation is that you don't deploy the distribution's Docker. You deploy stock upstream Docker. And we actually have a script on how to do that. Docs. Oh, I'm in the docs. Rancher 2.x. So we have a script that you just basically do a curl pipe sh, and it will installing Docker. Yeah, there you go. So it will figure out your operating system, and it will go and it'll get the latest of whatever this tag is, 1903 or 20.06 or whatever it is. You can change that. It will pull down the correct one from just stock upstream Docker. And that's what we test against, and that's what we have in our support matrix, and that's what we guarantee will work, because that's what we test against. As far as Kubernetes, same kind of thing. Yes, theoretically, you can install microK8s and import it into Rancher. No problem, it'll work fine. As long as it's a CNCF certified Kubernetes distribution, it'll work fine. There might be some special microK8s specific stuff that Rancher doesn't understand, but as long as you're just doing regular Kubernetes, CNCF certified Kubernetes distribution, you're good to go. Questions keep coming in. I'm going to keep answering them. Oxiel asks, if I have my old Docker K8 setup and I install a new RKE K3S cluster, are they compatible? May I migrate it without issues? Probably. As long as you're running the same Kubernetes version and your workloads are up to date for that version, then yes. So that's like Kubernetes 1.16, 1.17, 1.18, and so on. If you have a Kubernetes 1.4 and you're trying to move your workloads to Kubernetes 1.19, there are portions of the Kubernetes API that have been deprecated, and you'll need to update your manifests. So what I would recommend is that you bring your existing cluster up to the current place, make sure that all of your manifests are updated, for the API paths and stuff like that. And once that's done, then you can just take those and deploy them over here, and you'll be totally fine. You'll have to consider, this is where GitOps comes into play. Like, you might just want to take it and like GitOpsify it. It's not even a word, but I just made it up. And then point this at it over here. And that way you're still keeping this running. You're also pulling it over here. You can do some testing, and then you can repoint your IPs. Once again, just like a data center migration. Just bring it over here, test it. When you know it's good, do your thing. Data is where you're going to have the issue. If you have volumes over here, you need to get that data over here. And there are lots of ways to do that. You can SCP, you can DD, you can do NFS, you can do all sorts of things. So I leave that as an exercise to the reader. Okay. Oh, that was the last question. No more questions. I got like 5 slides and then we're out of here. Oh, man. If you want to know more about Rancher and RKE, we have the Rancher Academy. This is also totally free for you. So you can go to academy.rancher.com, and this is a 5-week course. If you spend 3 to 5 hours a week on it, it's a 5-week course. It's 87 labs. It's 4.5 hours of video. It's taught by me. So if you like the way I teach, you can go get more of me over there. Well, that was weird. There's like a weird echo. That's crazy. Okay, so anyway, if you like the way I teach, you can go get more of me over there. And yeah, and it's free. It ends with a certificate of completion. There's an actual final exam that demonstrates the knowledge that you've learned throughout it. This will go through installing RKE, deploying Rancher into RKE, using Rancher to deploy and manage Kubernetes clusters, and then lots of stuff around troubleshooting Kubernetes. It's actually about Rancher and RKE less than it is about Kubernetes. There's almost no, there's no kubectl stuff in there. Otherwise, oh yeah, we launched it in May of last year, and we had 1,000 signups on the first day. There's like 16,000 people that are signed up. We've issued something like that. Remember, Rancher user Slack, slack.rancher.io. That's where you go, join the community, hang out, come talk. I'm in there. There's an Academy channel. If you have questions or whatever, there's other Rancher engineers in there as well. Just come say hi. This is me. If I have earned the right for you to contact me and communicate with me, then I hope you do. I am the director of community. My sole purpose in life, at Rancher at least, is to make sure that you're successful with Kubernetes. So I sincerely hope that I've done a good job of launching you into space on your Kubernetes journey. And I want to thank you very, very much for spending so much of your day with me today. Stay safe. Have a great day. We'll see you later.